Our atmosphere contains a number of different gases. It's mostly made up of nitrogen, about 78%, and oxygen, about 21%. But it also contains a number of gases known as greenhouse gases. These include water vapor, carbon dioxide, methane, nitrous oxide, ozone, and chlorofluorocarbons, which are usually man-made. They're called greenhouse gases because the properties of these gases allow them to retain heat, leading to a warming of our atmosphere. Let's take a closer look at how this happens. Our sun produces light, which is composed of small particles, called photons. These photons pass through the atmosphere and collide with the surface of the planet. If the surface of the planet is lightly colored, such as areas that are covered by ice or snow, the photons may be reflected back into space. However, if the surface is darker, such as forests or oceans, the photons are absorbed. When this happens, some of the photon's energy is converted to heat, which radiates away from the surface. You experience this effect when you wear darker clothing outside. The dark fabric absorbs photons from the sun's rays, usually resulting in heat. This heat from photons, also called infrared radiation, radiates from the surface into the atmosphere. Most of this heat moves through the atmosphere and is lost into space. However, some of the heat interacts with greenhouse gases in the atmosphere, such as carbon dioxide, water vapor, and methane. These molecules absorb the infrared energy and slowly release it back into the atmosphere over time. It's important to realize that greenhouse gases play an essential role in the maintenance of our planet's temperature, helping it to stay within the limits that allow life to flourish. Normally, these gases are needed at very small concentrations, often in the magnitude of parts per million. In fact, if our atmosphere had fewer greenhouse gases, the majority of the water on the planet would exist as ice. However, human activities, such as the burning of fossil fuels and modern agricultural practices, have resulted in an increase in the concentration of some types of greenhouse gases, most notably carbon dioxide and methane. This graph shows the progressive increase in carbon dioxide concentrations over the past 5 decades. The concentration of carbon dioxide in the atmosphere is now over 400 parts per million, which represents a greater than 20% increase since the 1960s. This increase in carbon dioxide concentrations, as well as other greenhouse gases such as methane, is directly related to an observed increase in global temperatures, as shown on the graph here. This process is called global warming. As the planet warms, it causes changes in regional climates. This is commonly referred to as climate change. Scientists have already documented numerous cases where climate change is altering weather patterns, producing areas of severe storms, flooding, and droughts. At the current rate of greenhouse gas increase, it's projected that the average global temperature may increase by another 3.6 degrees Fahrenheit by 2100. However, the exact amount of warming that will occur in the coming century depends largely on the energy choices we make now and in the coming years, particularly since those choices directly influence how fast we put greenhouse gases into the atmosphere.